Low-frequency hearing thresholds predict cognitive performance, a comprehensive explanation. Overview and research context. This scientific paper, published in Scientific Reports, investigates an important and emerging question in cognitive neuroscience: can subtle variations in hearing ability, even within the clinically normal range, predict cognitive performance? The researchers, led by Shehzeen Abdulghafoor and colleagues from institutions in India and the United States, explored whether specific frequencies of hearing sensitivity are associated with working memory and attention in both younger and older adults. The study is particularly significant because hearing loss has been increasingly recognized as a risk factor for cognitive decline and dementia. However, most previous research has focused on individuals with clinically significant hearing loss. This study breaks new ground by examining people with clinically normal hearing, those who would typically pass standard hearing screenings, to determine whether minor variations in their hearing thresholds correlate with cognitive function. Study design and participants. The research included 99 participants divided into two age groups: 49 younger adults aged 18 to 35, mean age 25.9 years, and 50 older adults aged 50 to 70, mean age 55.8 years. All participants met clinical criteria for normal hearing, defined as a 4-frequency pure tone average below 20 dB. Importantly, the researchers used stricter criteria for younger adults' thresholds no worse than 15 dB compared to older adults' thresholds better than 25 dB at lower frequencies, acknowledging age-appropriate hearing standards. Cognitive and auditory assessments. Participants underwent comprehensive cognitive testing using several validated measures: working memory tasks, forward and backward digit span. Participants listened to sequences of digits and recalled them in either the same or reverse order. Operation span (OSPAN), a dual task requiring simultaneous arithmetic problem solving and word memorization. Reading span (RSPAN), a dual task involving sentence plausibility judgments and word memorization. Attention task, Erickson flanker task. Participants identified the direction of a central arrow while ignoring flanking arrows that were either congruent or incongruent with the target. Hearing sensitivity was measured using pure tone audiometry across octave frequencies from 250 Hz to 8000 Hz. This produced 16 threshold values per participant, 8 frequencies in each ear. Statistical approach and key findings. To manage the complexity of their data, the researchers employed principal component analysis (PCA) to reduce dimensionality. This statistical technique identified two distinct components of hearing: low-frequency LF component, loading on thresholds at or below 1000 Hz; high-frequency HF component, loading on thresholds at or above 2000 Hz. Similarly, PCA was applied to working memory measures, yielding two components: simple working memory forward and backward digit spans and complex working memory operation and reading spans. The flanker task measures were combined into a single attention component. Critical findings. Age-related differences. As expected, older adults demonstrated poorer hearing thresholds across all frequencies and performed worse on all cognitive measures compared to younger adults. This confirms the well-established pattern of age-related sensory and cognitive decline. Frequency-specific relationships. The most striking finding was that low-frequency hearing thresholds significantly predicted cognitive performance across all domains: simple working memory, complex working memory, and attention, even after statistically controlling for age. In contrast, high-frequency hearing thresholds did not independently predict cognitive outcomes once age was accounted for. Age as a shared factor. The researchers discovered that HF hearing thresholds were strongly correlated with age: R equals 0.556, P 0.001, while LF thresholds showed a much weaker age relationship: R equals 0.225, p equals 0.025. This suggests that HF hearing loss may primarily reflect general age-related changes, whereas LF hearing sensitivity captures something distinct, perhaps preserving aspects of auditory processing that remain functionally important for cognition across the lifespan. Theoretical implications and mechanisms. The researchers propose several interpretations of their findings: compensatory spectral reweighting. As individuals age and experience subtle high-frequency hearing loss, they may increasingly rely on low-frequency cues to maintain communicative success. This adaptation may extend beyond speech perception to influence broader cognitive resource allocation. Older adults may develop perceptual strategies that depend heavily on preserved LF information, potentially explaining why LF sensitivity becomes associated with cognitive performance. Beyond speech perception, importantly, the cognitive tasks in this study were not speech-in-noise tests. They used visually presented stimuli or speech presented in quiet. This suggests the LF-cognition relationship is not simply about difficulty perceiving speech sounds. Instead, LF hearing sensitivity may index broader aspects of auditory system integrity that interact with domain general cognitive processes, supporting stable perceptual representations and reducing the cognitive resources needed for task performance. Early marker of neurocognitive vulnerability. The findings suggest that subtle LF hearing declines could serve as early indicators of broader neurocognitive vulnerability, providing a potential window for early identification and preventive intervention. This is particularly important because LF changes occur independently of chronological age and may signal specific neural processes distinct from general aging. Clinical and practical significance. This research has important clinical implications. Rethinking normal hearing. Current clinical definitions of normal hearing thresholds less than or equal to 25 dB may be too lenient. Even individuals passing standard hearing screenings show cognitive associations with their LF hearing sensitivity. Frequency-specific monitoring. Rather than relying solely on pure tone averages or high-frequency testing, clinicians should consider monitoring LF hearing sensitivity as a potential marker of cognitive health. Early intervention window. Subtle LF hearing changes may identify individuals at risk for cognitive decline before more obvious hearing loss or cognitive symptoms emerge. Study strengths and limitations. Strengths include the comprehensive cognitive battery, sophisticated statistical methods controlling for age, and the focus on clinically normal hearing individuals, a population often overlooked in hearing cognition research. Limitations include the cross-sectional design preventing causal conclusions, modest sample size, and the need for longitudinal studies to track whether LF hearing changes precede cognitive decline. The proposed mechanism of compensatory spectral reweighting remains hypothetical and requires direct testing in future research. Conclusion. This study demonstrates that subtle variations in low-frequency hearing sensitivity within clinically normal limits predict cognitive performance across adulthood, independent of age. The frequency-specific nature of this relationship with LF but not HF thresholds explaining unique cognitive variance challenges traditional approaches to hearing assessment and highlights the importance of considering specific auditory frequencies when examining sensory cognitive interactions. These findings open new avenues for understanding how sensory and cognitive systems interact across the lifespan and may ultimately inform strategies for early detection and prevention of cognitive decline.